Hey. Jesus Lizard, where are you?
Sorry, honey badger. I got my legs stuck in a fence.
Whatever. We have some business to discuss today.
Yeah, discuss.
So in order for this plan to go down right, you need to know a little something about bonding and shapes.
Shapes!
Shut up! You're such a little dinkus. Look, we'll just start with the intermolecular bonding. Inter as in between bonds.
Bonds!
What is your problem? Anyways, we have ionic, polar covalent, and nonpolar covalent. Ionic bonds are between nonmetals and metals. The electrons are given away from the metals to the nonmetals with higher electronegativity. When you subtract the electronegativity in ionic bonds, it should be 8.1 or higher. In polar covalent, it is generally between nonmetals of different elements, and the electrons are not shared equally. When you subtract the electronegativity, it is between 0.4 and 1.7. In nonpolar covalent, electrons are shared equally, and when the electronegativity is subtracted, it should be below 0.4.
So interesting.
Not really. Anyways, if you have determined a molecule to be covalent, the next step is to find if it is polar or nonpolar. To do this, you have to look at the shapes. For example, you must start with drawing the Lewis structure, this thing. Then you look at how many electron pairs there are. In this case, there are 4. That's what the lines represent around the center atom. That makes it an sp3. To know what shape it is, you have to put it into its 3D... What are you doing?
Tú es un culo cabeza!
Anyways, when you put it into its 3D shape, you will notice that oxygen has a higher electronegativity than hydrogen, so there's a pull towards oxygen. And that makes this area negative and this area positive, making it polar. If the hydrogens were in a different bond with a different element and they were equally set apart, and then it would be nonpolar. Beat that.
Jeez, honey badger, you just gotta be better than everyone. Huh.
Of course I do. I'm Honey Badger.
Well, I'm the Jesus Lizard. I can run on water. See that? And I can talk smart too. So, intermolecular forces. These are the forces that hold together molecules. In order from strongest to weakest, we have hydrogen, dipole-dipole, and dispersion. Ionic molecules bound together by hydrogen bonds are by far the strongest combination. A dispersion force always holds together nonpolar molecules and dipole-dipole with polar molecules. The types of bonds and forces together immensely affect properties, physical properties. As I said before, ionic with hydrogen is the strongest. This means that it will have a very high boiling point, it will be the most difficult to dissolve, and it would be the best conductor of electricity when dissolved in water. As combinations of the forces become weaker, the boiling point lowers, it will be easier to dissolve, and it becomes less and less of a good conductor. What?
Whatever. Honey Badger out.